Myself, Kadruli from AIDS department, A section.
In this video, we are going to see about logic gates, implementation of logic gates and characteristics of logic gates. In this, we can see AND gate, OR gate, NAND gate, NOT gate, XNOR gate, 3 input NAND gate and XOR gate. Here you can see a many number of logic gates. From here you can drag the logic gates and you can customize logic diagram. From this output control, you can see the output bulb. From this output bulb, you can customize the output of the logic diagram. From this input control, you can drag the input controls to your page and you can customize the logic diagram. In the AND gate, if you give both the input as 0, the output will be 0. If you give one input as 1 and another input as 0, the output will be 0. If you give both the input as 1, the output will be 1. In the OR gate, if you give both the input as 0, the output will be 0. If you give one input as 0 and one input as 1, the output will be 1. If you give both the input as 1, the output will be 1. In NAND gate, if you give both the input as 0, the output will be 1. If you give one input as 1 and another input as 0, the output will be 1. If you give both the input as 1, the output will be 0. In the NOT gate, if you give the input as 0, the output will be 1. If you give the input as 1, the output will be 0. In the XNOR gate, if you give both the input as 0, the output will be 1. If you give the one input as 1 and another input as 0, the output will be 0. If you give both the input as 1, the output will be 1. In the 3 input NAND gate, if you give all the 3 input as 0, the output will be 1. If you give the one input as 1 and another 2 input as 0, the output will be 1. If you give all the input as 1, the output will be 0. In XOR gate, if you give both the input as 0, the output will be 0. If you give one input as 0 and another input as 1, the output will be 1. If you give both the input as 1, the output will be 0. In this, we can see off adder, full adder, half subtractor and a full subtractor. In off adder, if you give both the input as 0, the sum will be 0 and the carry will be 0. If you give one input as 1 and another input as 0, the sum will be 1 and the carry will be 0. If you give both the input as 1, the sum will be 0 and the carry will be 1. In the full adder, if you give all the 3 input as 0, the sum will be 0 and the carry will be 0. If you give one input as 1 and another 2 input as 0, the sum will be 1 and the carry will be 0. If you give two inputs as 1 and another input as 0, the sum will be 0 and the carry will be 1. If you give all the 3 input as 1, the sum will be 1 and the carry will be. In the off subtractor, if you give both the input as 0, the difference will be 0 and the borrow will be 1. If you give one input as 1 and another input as 0, the difference will be 1 and borrow will be 1. If you give both the input as 1, the difference will be 0 and the borrow will be 1. In the full subtractor, if you give all the 3 input as 0, the difference will be 0 and the border will be 0. If you give any one input as 1, the difference will be 1 and borrow will be 0. If you give two input as 1 and another input as 0, the difference will be 0 and borrow will be 0. If you give the three input as 1, the difference will be 1, borrow will be 1. In this, you can see binary to gray code converter and gray to binary code converter. In the binary to gray converter, if you give three input as 1 and another input as 0, the G3 and G0 will be 1 and G2 then G1 will be 0. In the gray to binary converter, if you give G0 as 0, G1 as 1, G2 as 1 and G3 as 0, the outputs are B0 as 0, B1 0, B2 1 and B3 0. Here you can see BCD to XS3 code converter and XS3 to BCD code converter. If you give all the four input as 0, the E1 will be 1 and E0 will be 1. If you give B0 as 1, the output will be E2 will be 1 and all others are 0. If you give B1 and B0 as 1, and E2 and E1 will be 1. If you give B3, B1 and B0 as 1, the output will be E3 will be 1 and E0 will be 0, E1 will be 1, E2 will be 0. In XS3 to BCD converter, if you give X1 as 1, X2 as 1 and X4 as 1 and X3 as 0, the A will be 1 and C will be 1 and the remaining outputs are 0. If you give X1 as 1, X2 as 1, X3 and X4 as 0, the output will be A as 1 and B as and D as 1. If you give X1 as 1 and remaining input as 0, the B and D output will be 1 and the remaining output will be 0. Here we can see priority generator. In the priority generator, if you give all the three input as 0, the even priority is 0 and the odd priority is 1. If you give A input as 1 and B input and C input as 0, the even priority is 1 and odd priority is 0. If you give A as 1, B as 1 and C as 0, the output are even priority is 0, odd priority is 1. If you give all the three input as 1, the even priority is 1 and odd priority is 0. In this we can see multiplexer and demultiplexer. If all the inputs are 0, the output will be 1. If you give S0 as 1, I0 as 1, the output will be 1. If you give S0 and S1 as 1 and I0 and I1 as 1, the output will be 1. In demultiplexer, we are taking two selective inputs and one input. If you give all the three input as 0, the output will be 0. If you give one input as 1, the D0 will be 1. If you give S2 as 1 and input as 1, the D2 will be 1. If you give all the three input as 1, the D4 will be 1 and the remaining outputs will be 0. If you give S1 as 1 and input as 1, the D2 will be 1 and the remaining will be 0.